Hello, welcome all. So today we will discuss about the performance parameter and the heat balance sheet of an IC engine. So as far as the heat balance sheet is concerned, we used to maintain this particular heat balance sheet in the case of an IC engine in order to calculate the performance of an IC engine. But on what criteria these performance are measured? This is what is a major challenge. So performance parameter inside the engine is an indication of the degree of the success with which it does its assigned job, that is conversion of chemical energy contained in the fuel into the useful mechanical work. In evaluation of the engine performance, certain basic parameters are chosen and the effect of various operating conditions, design concepts and modifications on these parameters are usually studied. So these basic performance parameters are performance and mechanical efficiency, mean effective pressure and torque, specific output, volumetric efficiency, fuel air ratio, specific fuel consumption, thermal efficiency, smoke and emissions, specific weight. So on the basis of this we used to calculate that how much heat is generated inside the engine and how much is converted into the useful mechanical work. So as far as the heat generated is concerned, we have to see that what is the conversion efficiency in order to convert the energy content which is in the fuel into the useful heat energy. So when we deal with the heat balance sheet, we used to divide this particular heat balance sheet in two particulars. First is credits, second is debits. Credit consists of the heat generated inside the engine in kilojoule per minute as well as in the percentage content. As far as the debits are concerned, we used to calculate the debits means whatever the amount of heat energy which has been consumed inside the engine in order to generate some mechanical output. That is also taken in kilojoule per minute and in the percentage content. QS is what? QS is the heat generated. QB is heat equivalent to the brake power. QW is heat lost by the cooling water. Qg is heat lost by the gases, and this one is unaccounted heat. But before this particular heat balance sheet is maintained, we have to see that what is the actually unaccounted heat, and we have to perform certain tests also. So in order to conduct the test on a IC engine, we have to prepare a heat balance sheet. But whenever we have to make a heat balance sheet, we require some apparatus. First is a IC engine setup, measuring tape, thread or a scale, tachometer, stopwatch, bucket, spring balance, thermometer. So as far as the theory and the description of the heat balance sheet is concerned, a heat balance sheet is nothing but just an account of a heat supplied and the heat utilized in various ways in the system. Necessary information concerning the performance of an engine is obtained from the heat balance sheet. The heat balance sheet is generally done on the second basis or a minute basis or a hour basis. The engine should be equipped with a suitable loading arrangement to measure the brake power of an engine. Provisions are also made to measure the amount of air intake, amount of fuel consumed, temperature of a cooling water at inlet and outlet of the engine, amount of cooling water circulated and the temperature of the exhaust gases. All these parameters are also nowadays taken into care because there is a lots of research which is going on the alternate fuels. So when we all one day or the other, nowadays we are dependent on the fossil fuels. So it is leading us towards the twin crisis of fossil fuel depletion and the environment degradation. So we people as a student, as a teacher or as a researcher has to move on one day or the other another day to some other alternate fuels. So lots of research is going on to the alternate fuels, due to which a heat balance sheet also plays an important role in order to take the performance analysis, in order to take the emission analysis, as well as in order to get the optimum result of any alternate fuels for its utilization in a IC engine. So as far as this heat balance sheet is concerned, the heat supplied to the engine is only in the form of a fuel, and that heat is equals to the mass of fuel used inside the engine and the calorific value of that fuel which is used inside the engine. That is mf equal to mass of fuel used in kilogram per minute, cv equals to calorific value of the fuel in kilojoule per kilogram. So this is what is the actual amount of fuel which has been generated inside the engine by the fuel. So as far as the procedure is concerned, first of all we will get the details from the nameplate of an engine, calculate the maximum load that can be applied on a given engine or a given set of engine, check the engine for the fuel availability, lubricant and the cooling water connections, release the load on the engine completely and start the engine with no load condition. Allow the engine to run for a few minutes to attain the rating speed, adjust the cooling water flow and maintain the steady flow of water. Apply the load from the no load to the required load gradually or slowly, and at the time of the loading, when the required load has been attained, we have to note down some important notings or important readings. These readings are: what is the load on the engine, what is the speed of the engine at that particular moment of time taken for the 10 cc 10 cubic centimeter of a cubic capacity of a fuel consumption, manometer readings, temperature of cooling water at the inlet point and at the outlet point, time taken for the collection of 5 liter or 10 liter of cooling water, room temperature and the exhaust gas temperature, which is nowadays also called as EGT. When we got such details, we used to maintain this particular sheet, or we used to make out this particular sheet. Let us suppose we have generated x amount of x kilojoule per minute amount of energy. So what is that energy in percentage? That is what is 100%. Now we presume that x minus x1 amount has been consumed in the brake power heat. X minus x2 amount is consumed in the cooling water. X minus x3 amount is consumed in the unaccounted losses which has not been taken care while we are working on the engine. So on this particular slide we will use to give their percentage. Let us suppose that is 27%, another one is 31, another one is 19 and so on. So this is what is the perfect sheet of an engine on which we use to calculate that how much energy is generated, how much energy is wasted and how the certain energy are generated and calculated. Some basic formulas used in this type of calculation or these analysis are that heat equivalent to the BP or a brake power is, the brake power is in kilowatt and it is converted into kilojoule per minute. So that is what is BP into 60, that is whatever the answer is, that is in a kilojoule per minute. Heat carried away by the cooling water is QW, that is equals to mass of the cooling water in kilogram per minute into specific heat of a cooling water, which is generally taken as 4.186, into temperature of the cooling water at the outlet in degree Celsius and the temperature of the inlet water, cooling water at the inlet in degree Celsius. So these type of basic formulas can be used in order to get these particular heat balance sheet. Now the important thing is this amount of heat which is called as unaccounted heat. So this is what is Qg is equals to, one more heat is as far as the Q unaccounted is concerned, we will go for the calculation of a Q unaccounted, that is what is Q shaft minus Q into BP plus Q into cooling water plus Q into gases. So net amount of heat generated minus net amount of heat which has been debited from the engine, debited by the engine in order to convert the useful work, that is what is the net amount of unaccounted heat. One more heat is also deployed inside the engine, that is what is heat carried away by the gases. So that is equals to mass of the exhaust gases in kilogram per minute into temperature at the outlet minus temperature at the inlet in degree Celsius into specific heat of the gases, that is generally taken as 1.005 kilojoule per kilogram Kelvin. So when all these values are calculated, then we use to maintain this particular heat balance sheet, and this heat gives us the idea of the performance of the engine, that how much performance is carried away by your setup of engine. and what are the necessary modifications which are required in order to in order to generate the maximum efficiency. So this is what is the concept of a heat balance sheet. And as far as the performance parameters are concerned, these 9 parameters are the basic performance parameter on which any engine is supposed to be evaluated. So in the next class we will discuss about the different parameters or the performance analysis and the emission analysis of a IC engines. Thanks for the listening.